Here's the synaptic vesicles with the acetylcholine inside. Here's the muscle. Here's the myosin filaments. Here are the actin filaments. There is a T-tubule with its surrounding cisternae filled with calcium ions. The first thing you got to be able to know is you got to be able to do that. You got to be able to set the whole thing up. If you can't set it up, then you don't understand it. Okay, so you got to know all that. Okay, so now an action potential comes down the motor neuron, causing these synaptic vesicles to release the acetylcholine on the sarcolemma.
And there's actually 6 actin filaments, not only 4. You always draw 4.
Yeah, but it doesn't. That's not important.
It's not important.
The only reason I mentioned it was just to give you a perspective that it's a cylinder, not a two-sided thing. So, acetylcholine, when it's released on the sarcolemma, creates an action potential of its own. And that action potential opens gates just similar, but not exactly the same as on a neuron, and allows sodium ions to rush into the T-tubules, down the T-tubules. So, the movement of the sodium ions down the T-tubules is the action potential on the sarcolemma. So you got 2 action potentials. This one, releasing acetylcholine, and this one, allowing the sodium ions to rush into T-tubules. When these sodium ions rush through the T-tubules, that stimulates the release of calcium ions. They flood over the myosin and actin filaments. The presence of the calcium ions allows the myosin heads to attach to actin, and the myosin then draws actin filaments together, and the muscles contract. Now, while that's going on, there's also an enzyme up here called acetylcholinesterase, and as soon as acetylcholine is released, acetylcholinesterase is breaking down acetylcholine. When acetylcholine is broken down, these channels close, and the sodium-potassium pump pumps the sodium ions back out on the muscle membrane, repolarizing the muscle membrane, repolarizing the sarcolemma. When the sodium ions disappear from inside the muscle cell, the calcium ions are stimulated to return to their cisternae. And when the calcium ions are gone, that causes the myosin heads to break away from the actin filaments. And the actin filaments spring back to their original shape, which is relaxation. So, you understand it when, like I said, when you can see that happening, like with your eyes closed. You can see the action potential coming down the motor neuron, the acetylcholine being released, the sodium ions rushing into the T-tubules, the calcium ions spreading out over the actin and myosin filaments, myosin heads attached, draw the actin in, acetylcholinesterase breaks down the acetylcholine, sodium ions get pumped out, calcium ions go back to their cisternae, myosin breaks a bond with actin, and the actin filaments spring back. Don't have to worry about the potassium ions, either in this or the neurological one either. I just mentioned those because they're there.
Do we need to know